Hello, today's lessons on quadratic equations and quadratic functions. So, let me begin with this quadratic equation. Any equation of the form that Px equals to 0, that any equation or any polynomials you can say where Px is a polynomial. Of degree 2 is a quadratic equation. So, what does it mean? The degree 2 is the power of x, or the exponent is 2. Now, quadratic equation in the variable x, a quadratic equation in the variable x can be expressed as ax square plus bx plus c equals to 0, where a cannot be 0 and all a, b, c belongs to the real numbers or real constants, whatever you can say. Now, in general, a real number, say alpha is a real number. This number is called the root of the quadratic equation or the solution of a quadratic equation if and only if we key the alpha in form of x, then a alpha square plus b alpha plus c equals to 0. This satisfies the condition. The whole equation would be that left hand side equals to right hand side. Then we can say that alpha is a root or the solution of x. We can also say x equals to alpha and is a solution of the quadratic equation. Or even if you consider it as a quadratic polynomial only Px, then alpha can be treated as a 0 of the quadratic polynomial. Why it is called so? Because when we graphically represent any quadratic functions, we will see that function will intersect with the x axis, that is give our solution for the quadratic equation or even 0 for the quadratic curve. So, what this solution or the roots or the zeros imply? It implies that where this x axis intersects with the quadratic function or curve or even in form of equation, if we find the solution, we will see that if it is our x axis, then our quadratic curve is intersect at these 2 points, what we call 0 solution or the root of a quadratic equation. Now, this quadratic equation or this function, if you plot on a graph, it always gives a parabola. Now, for moving for this solution, so we can solve this kind of expression ax square plus bx plus c equals to 0. This equation can be solved either by factorize and use null factor law, This means null factor law is if you factorize something like x into y equals to 0, then we can say either x equals to 0 or y equals to 0. And second thing is the use quadratic formula. Now, for method 1 as well, like what we call the factorize and use null factor law, if you express this ax square plus bx plus c equals to 0, by trial and error we can find out the factor of this expression, and we can express this expression as x minus alpha into x minus beta equals to 0, or we can say a into. Okay. So, this is then I have two solutions for x. I will find x equals to alpha and x equals to beta. And one more thing, as x is power 2 this expression, then this quadratic curve can only meet x axis maximum at 2 points. So, we cannot find more than 2 solutions for quadratic expressions. Now, again we can do it as a perfect square. We express this expression as a perfect square. So, for perfect square, the expression would be a into x, either plus minus alpha depending on the sign it is having, equals to 0. And for this kind of thing, when we can express it as perfect square, the two roots would be identical, means two same roots, x equals to either plus alpha, or when x minus alpha square, x will be minus alpha. Then we have two identical roots, means one solution for x. This means here this quadratic curve just touches x axis at one point. Here it is intercepting at 2 points, alpha and beta. Here it is x axis is only touched by 1 point. Now, apart from that, we can express this thing. When we cannot get a perfect square, then what we are doing, difference of two squares. And what is that? Difference of two squares means this a common. So, x square minus alpha square equals to 0. So, a x plus alpha into x minus alpha equals to 0. Then x equals to plus minus alpha. This kind of expression also we can find for the solution of the quadratic equation. Now, for this thing, let us take some examples to solve. Let us solve this one, x square minus 5x minus 14 equals to 0. So, I am simply using the factorization method. What is the factorization method? For this coefficient is 1, I can see. So, 1 into 4 is 14. Now, if I am LCM this 14, what I am getting? 2, 7. Now, say I can arrange this 2 and 7 like 7 minus 2 to get a 5. This is called the midterm break. So, according to the sign, if I can arrange this thing, I can find x square minus 7x plus 2x minus 14 equals to 0, or x minus 7 and x plus 2 equals to 0. Now, using the null factor law, that either x minus 7 equals to 0 or x minus 2, x plus 2 equals to 0. Sorry, yeah, x plus 2 equals to 0. This gives me two solutions for x, x equals to 7 and minus 2. And furthermore, not always will find this kind of easier kind of equation to solve. Let us see this one. Now, how to solve this? To solve this, we need to first taking this coefficient of x square out of this expression. So, now the expression becomes 2 by 3x minus 2 by 3 equals to 0, or 3. Now, I am applying that a plus b whole square formula to make a square out of this. X square 2 into x, that is my a, into 1/3, I cannot disturb this thing. So, if this is my b, so my b square would be 1 by 9. Again, I cannot disturb the balance, so subtracting 1 minus 1/9 minus 2/3 equals to 0, or 3. Here I am getting x plus 1/3 whole square minus 9. So, 1 plus 6 equals to 0, or x plus 1/3 square minus, now see square root by 3 whole square. So I am expressing this term as also a perfect square. Now here it is the difference between squares of two numbers. So x plus a into x minus a formula applying, I am getting x equals to minus 1/3 plus minus root 7 by 3. So this is the solution for x. These are two solutions. Now here comes our method 2 using the quadratic formula. Whenever the quadratic formula will come, the discriminant is very prominent in our quadratic formula. What is that? Now, when factorization or squaring is not possible, some typical kind of thing is given, either way you have to use the calculator, or here it is when for any paper you cannot use the calculator, you can use the quadratic formula for finding out the solution of x. Now, quadratic formula for the expression x square ax square bx plus c equals to 0 can be given by x equals to minus b plus minus square root of b square minus 4ac divided by 2a. The earlier example, what I have done, the similar way this expression can be split out to find out this kind of root of quadratic formula, that's what we are calling it. So simply if you are keying it ABC into the earlier example, you will find that x equals to minus b plus minus b square minus 4ac square root divided by 2a. Now this b square minus 4ac is called discriminant. Now this discriminant also symbol is there, this symbol is called delta. Now we can see the solution of x highly dependent on this discriminant, this b square minus 4ac expression. So we see that when this delta or the discriminant greater than 0, what will happen? This expression ax square plus bx plus c can be factorized. Then this expression we can see that can be factorized, ax square plus bx plus c equals to 0 can be factorized and have two real unique solution. When this discriminant equals to 0, then also this expression can be factorized and having one real solution. Means actually two solution, but it is repeated. Identical two solution means one real solution. And when this discriminant is less than 0, see some quantity less than 0 under the square root, it is not a real number at all. So in that case, the expression ax square plus bx plus c equals to 0 cannot be factorized. Cannot be factorized and no real solution exists. No real solution exists. Now take this example that find k if equation x square minus k plus 3x plus k plus 6 equals to 0 has one root, two real root or no real roots. Now we need to find out the del first, the discriminant. So delta equals to b square minus 4ac. Here b square is k plus 3 minus k plus 3. So it is minus k plus 3 whole square, square would be outside, yeah, minus 4a, a is my 1, coefficient of x is 1 and c is k plus 6 equals to 0. So, that gives me again one quadratic equation, that k square plus 2k minus 15 or k plus 5 or k minus 3. So, for the solution we have only one solution, this del would be 0. So, del is this thing, therefore, del equals to 0 for a. So, k plus 5 into k minus 3 equals to 0. Therefore, k would be, we can say that k belongs to this kind of expression, minus 5 or 3. Or this thing, sorry, that k. Now, for b, for two real roots, this expression that k plus 5 into k minus 3 should be greater than 0. Now, for that there will be two solutions, that either k is greater than 3 or k would be less than minus 5. To satisfy this equation, we can see, okay, that inequalities to multiplication, when we are interchanging, that when k plus 5, because you see these two thing, it is a multiplication thing, when two multiplication give a product of positive thing, either way this k plus 5 or k minus 3 both are positive, or k plus 5 and k minus 3 both are negative, then they are greater than 0 will give us a positive thing. Hence, therefore, we find that k plus 5 is less than 0, then we have both are negative, that k in a single thing I can write that k either be less than minus 5 or k greater than 3. So, in the number line, if I am plotting it, it should be something like that. If this is 0, then 1, 2, 3 and it will be extended over here, minus 1, minus 2, minus 3, minus 4, minus 5. So, this is minus 5. So, from this point I won't put a solid dot, sorry. So, this, change the color. So, it is something like that, the value of k, and we can express it similarly, the union of the two sets, that k less than 5 union k greater than 3. So, this would be my one solution for two real roots and no real root. For no real root, this value would be k plus 5 into k minus 3 be less than 0. So, that gives me that this value should be in between this number line. So, I can say, write using a diagram also I can write, or this is in the same diagram I have done it. So, k would be in between, it will take the in between value, sorry, k would be, this is my minus 5 k 3, this also not touching. So, that would be my another condition for no real roots. Now comes to the quadratic functions. The same way, a quadratic function has general form of f(x) equals to ax square plus bx plus c, and a not equals to 0 and a, b, c all belongs to this real constant or numbers. Now, all quadratic functions, whatever quadratic functions we can imagine, all quadratic functions are parabolic. Have parabolic graph. And have a vertical axis of symmetry, and have vertical axis of symmetry. Now, if in this parabolic graph the expression is ax square plus bx plus c, now when a is greater than 0, then the parabola is concave up. Parabola is concave up. That means it would be something like that. And if a less than 0, then the parabola is concave down. Hence, the graph would be like this way. Now, look at the general properties of this kind of function or the graph. First, we get the y-intercept. Now, what is y-intercept? It only happens when x equals to 0. This graph will cut at the y-axis. So, if we consider x equals to 0 and just putting the value of 0 over here in place of x, what we find? We find that fx equals to c. Then what will be my coordinate, or the points would be that this graph passes through at 0 and c. This is the coordinate of y-intercept. Now, second properties, I will see that x-intercept. This x-intercept, this is what we call the 0 or the solution or the roots of the quadratic equations for this curve or function. We can say that zeros or the x-intercept. Now, this only occurs when if x itself becomes 0. Therefore, just simply placing in value of 0, we are getting the same quadratic equation, and the quadratic equation we already know by formula. It should be 1 is minus b plus square root of b square minus 4ac. Now, you see again here this discriminant plays a vital role, or minus b square minus 4ac by 2a. This means my x-axis being intersect at these 2 points by my function ax square plus bx plus c. So, coordinate would be this and 0 as y is 0, and it is on the x-axis. Now, it is coming the axis of symmetry. We can easily get by these two, averaging out this 2 value of x-axis. Suppose I am writing in short, if x equals to alpha and x equals to beta, then my axis of symmetry would be alpha plus beta by 2. So, by averaging out these two, what I am getting, this del is nullifying, and I am having my axis of symmetry occurs at x equals to minus b by 2a. Now, as my axis of symmetry is there, so my turning point or the vertex of the parabola would also lie on that axis of symmetry. So, how do I find out the coordinate for this? Now, simply I am having that x equals to minus b by 2a. So, for y value what I will do, again I will put the function value at x equals to b minus b by 2a. That would be my coordinate, and that is my, I can also say this is the vertex or turning point of quadratic function, means my parabola. This is the turning point. Now, consider this parabola. The same equation I am first what equation is solved, I use the same equation for using a graphing calculator for this parabola. I am finding the root. You see these two roots of this graph is, one is d and one is e, and this is 2 0. So, minus 2 0, sorry, minus 2 0, and this is 7 0 7 0. For equation I will say these are my solutions. For the graph I will say these are my zeros or the x intercept. This is my x axis and this is the y axis. This is x and this is y, right. So, this is the turning point. The turning point, again to find the turning point I said that first we need to find out the axis of symmetry. So, just averaging out these two, 7 plus minus 2, so minus by 2 gives me 5 by 2 equals to 2.5. So, this is my 2.5, and keying this value of 2.5 in my original equation, I am finding that it is coming at 20.25. So, this I can call the vertex or turning point, and this is the y intercept where this curve, this parabola intercept with the y axis, and this is y intercept is found by 0 minus 14. Now, see what is the geometrical interpretation of and the discriminant, the graph. The discriminant and geometrical interpretation. So, wherever this delta or the b square minus 4ac is greater than 0 and a is whether positive or negative whatever, if it is greater than 0, then if this is the x axis, the parabola definitely intersect the x axis at 2 points. Now, it depends on if a greater than 0, it would be concave up, and if a is less than 0, the parabola would be concave down. So, this is my first case. Now, second, I know that my delta or that b square minus 4ac, it is equal to 0. That gives, when x axis is like this, the graph or the parabola just touches the axis at a single point. Depends on a, if a greater than 0, it would be concave up, if a less than 0, it would be concave down. Now, then what does it imply? it is less than 0. Graphically, you have seen that this is the x axis, then the parabola is not touching the axis at all. There is no x intercept with the graph. So, again if a greater than 0, it would be concave up, a less than 0, my graph would be concave down. The sketching of the quadratic function can be done in two methods. One is intercept method. The method 1, intercept method, if this is my expression is given for a quadratic function, you can say fx or even y as well, then we have to first like that we factorize and we find that okay, it is like this way. Suppose a like this way, we find out the factorization method. Then we have two intercept point of x axis, that is alpha and beta. So their coordinate would be alpha 0 and beta 0, and when we find that what is my y intercept, that is x is 0. So finding the value of y intercept, I can find that y equals to a alpha beta. So the coordinate would be 0 a alpha beta, and using this 3 point I can plot a parabola like this way. Or method 2, I can follow this method as well, that is the turning point form, where the expression ax square plus bx plus c can be expressed as y equals to a into x minus h whole square plus k, where I can say that turning point would be h and k, and again finding the y intercept where x is 0, and for these 2 points again I can plot like this way a parabola. But I think that this kind of plotting you can also find out that axis of symmetry, so that you can make it equidistant when you are doing a freehand drawing for the sketching of the quadratic functions. Now finding equation from a graph. Now consider this, the graph, this is the graph you have given. So what you have point A, B, that is your x intercept and your y intercept. So from the graph you can see that your two x intercepts, the coordinate would be 1 0, here it is 5 0, and here it is 0 4. So with this information we can find the quadratic function to be expressed. We will simply use that fx equals to k into x minus alpha into x minus beta, this expression. So what we will do, we will keep first this information that fx equals to k x minus 1 to x minus 5. Now in this expression I will put this y intercept over here. So what I am having, 4 equals to k, for 2x as 0, so minus 1 into minus 5 is 5. So k equals to 4 by 5. So my quadratic expression would be fx equals to 4 by 5 x minus 1 x minus 5. Sorry. So when this information is given to x intercepts and the y intercepts, we can find our quadratic function by this way, using this form of quadratic equation. Now in the second thing what we are seeing, it is this way. Here it is given, it is only one point touching, and I am also having my y-intercept. So, what I am having, I can say that this is my turning point. So, turning point is in the middle, so it would be a minus 3, 0, and this is my y-intercept is 0, 2. So, simply I will use this turning point expression, that f(x) equals to k into x minus alpha whole square. Why? Because it is only touching, so perfect square I am using, it is perfect square. So, again I am having my expression is f(x) equals to k into x minus 3, so x plus 3 whole square. So, again putting this value over here, it is 2 equals to k into 9, so k equals to 2 by 9. So, this expression can be expressed as y equals to 2 by 9 k plus 3 whole square. So, this is another way for this information I can find it out, the quadratic expression. For that thing I have to key it in the perfect square expression. Apart from that, I can have this kind of, then what I have to do, I have to use the same like the previous perfect square, and there is an up, so something has plus already into that expression, that is f(x) equals to k into x minus alpha whole square plus beta. So, this is my turning point. I already expressed that. You can write it either way, x minus h whole square plus k. And then you can consider here some different kind of constant like alpha, hk or alpha beta, whatever I want to do. Now, you see here for this, it is my 3, 2, the turning point. So, I can express it that f(x) equals to k into x minus 3 whole square plus 2. Now, again I am having this, my y-intercept is 0, 6, this is the y-intercept of the function. Now, placing the value 6 equals to k, again it is 9 plus 2, I am having that k equals to 4 by 9. So, this function can be expressed like this way, that 4 by 9 x minus 3 whole square plus 2, or I can write that f(x) equals to 4 by 9 x minus 3 whole square plus 2. So, from the graph also I can find the quadratic expression using this, as it is not touching my x axis. So, something has been plus, so that is why this expression I am using. Now, for this kind of quadratic expression, how do I find the expression? I can see I am having 3 points over here. One is 0, 0, one is 6, 0, and here it is I am having that 1, 2. So, I know my quadratic expression, it will be here. Quadratic expression is ax square plus bx plus c equals to 0, and I am having 3 points. So, I can get that ABC. So, here first 0, 0, I am having that my c equals to 0. Well, now placing 1 and 2, this value that y equals to 2 and this is my x. So, a plus b equals to y, so it is 2, and then for 6 I am having 36a plus 6b C is already 0, so I am not writing it, equals to again 0. So, if I take that 6a and 6b into 2, so 2 into 6 plus 30a equals to 0. So, a equals to minus 12 by 30, nullifying the factor 6, it is 2 by 5 negative. So, what I am having as expression, it is y equals to minus 2 by 5 x square and b okay, I have to find it out, b over here, yeah, b equals to 2 plus 2 by 5, so it is 12 by 5. So, plus 12 by 5x and c is already 0. So, you can take the common x minus 6. This is the expression for this quadratic function. I hope I already clear everything on this quadratic equation and function. If you find any doubt or any problem in solving when the actual exercise you are practicing, please let me know in the comment box below, and thank you.